The term power provides a useful basis for choosing the type of motor or machine which is required to do a certain amount of work in a given time. For instance, two different pumps may each be able to empty a reservoir if given enough time. However, the pump having the larger power, which can do more work in the same amount of time, will complete the job more quickly. The instantaneous power generated by a force that performs a differential amount of work du in time dt is defined as follows, where power p, a scalar quantity, equals du over dt. That's the differential amount of work done over the differential time dt. Noting that du equals vector f dot vector dr as we learned earlier in chapter 14, then we also have the following, where the scalar p equals du over dt, that equals vector f dot vector dr over dt, that equals vector f dot dr by dt, and that equals vector f dot v, where v is the velocity, dr by dt. Thus, if the particle, such as the block shown below, has an instantaneous velocity v and is being acted upon by the 150 Newton force, as we see in this example below, then the instantaneous power supplied by the man here can be calculated using this formula, where power p equals the vector f dot vector v. Note that power is a scalar quantity that has typical units of watt, uppercase W, where 1 watt is defined as 1 joule per second, or we can use foot-pound per second in the US customary system, or horsepower HP, where 1 horsepower equals, by definition, 550 foot-pound per second. If the work done by a force during a finite time delta t is denoted as delta U, then the average power of the force during this finite period of time is calculated as follows, where the average power, P sub average, equals delta U over delta T. The mechanical efficiency of a machine is defined as the ratio of the output of useful power produced by the machine to the input of power supplied to the machine, where Greek letter epsilon is used to denote efficiency. So we have, by definition, epsilon efficiency equals power output over power input. If the energy supplied to the machine occurs during the same time interval at which it is drawn, then epsilon can be expressed as follows in terms of energy, where epsilon equals energy output over energy input. Note that epsilon, mechanical efficiency, is a unitless value that is always less than 1, since frictional forces are developed within a machine, and therefore extra energy or power is needed to overcome these forces. That is to say that power output is less than power input.